Hi, this is information for Unit 6, and for this unit I have an example that comes from a study that Doug Snyder did comparing different approaches to couples therapy. So if you have a couple, say a married couple or some other type of couple, and they're experiencing some relationship distress, maybe they're having a lot of conflict and they're having difficulties resolving the conflicts in their relationship. What are types of therapy that a couple might receive so that they can make their relationship better if they want to try to improve their relationship? Well, here I have a list of several different types of couple therapy. All these approaches listed here are approaches that have been tested in previous research studies. And for our example here, the study that was conducted by Doug Snyder, this study compared two of these approaches with a third group that received a control group that did not receive any therapy. The first group received behavioral couples therapy. This is an approach to couples therapy where couples are taught communication skills for resolving conflict. What are ways that you can express your own viewpoints so that a partner is likely to understand and be able to hear what you're saying and what your concerns are? What are rules couples can follow so that they can listen to each other and not misunderstand each other and make progress towards reaching resolutions in conflicts? So behavioral couples therapy focuses on communication skills for resolving conflicts. The other approach that was used in Doug Snyder's study, in fact, this is actually an approach that Doug Snyder himself developed called insight-oriented couple therapy. And this approach uses some of the same types of communication skills that behavioral couples therapy uses, but it also includes this insight component. And this involves having partners think about their previous experiences growing up in life, their experiences in their families of origin when they were children, experiences maybe in other relationships, and how those experiences have shaped them and given them information about what relationships are like, what to expect in relationships, what are the rules you follow in relationships, what are the standards and expectations you have in relationships. And so people are taught to get this insight about their previous life experiences and how that shapes who they are now and shapes the way they approach their current relationship. So it involves both insight and some communication skills training as well. So this particular study is going to compare one group receiving behavioral couples therapy, another group receiving insight-oriented therapy, and a third group is going to be a control group receiving nothing, at least not during the course of the study. Specifically, here's the design for the study. So all the participants in this study are couples that are seeking relationship therapy. Actually, these are all married couples, and they're seeking marital therapy for relationship distress. They were randomly assigned to one of three groups. So here we have a group, the insight-oriented therapy group. There were 30 couples received insight-oriented therapy. 29 couples were assigned to the behavioral couple therapy group. And then there were 20 couples in the control group, and these couples were put on a waiting list. They did not receive any therapy over the course of the study. And then when the study was all over, they were offered therapy if they wanted to receive some at that point. So couples were randomly assigned to three groups. Then at the end of treatment, they completed an outcome variable to measure their overall level of relationship distress. They completed a global distress scale on something called a marital satisfaction inventory, or the MSI. That's actually a questionnaire that Doug Snyder developed himself. Makes sense. It's his study. He's designing it, so he uses his own measure to test their level of distress at the end of the study. The process is for the people receiving treatment. There were 5 different therapists, and each therapist was trained to do both types of therapy. So each therapist might do behavioral couples therapy with a few couples and might do insight-oriented therapy with a few other couples. And so each couple received one of the 5 therapists, and each therapist did both types of treatment depending on what condition a couple was in. And the people receiving treatment, it went for 3 months. They met twice a week with their therapist. The couple came in, met twice a week with their therapist over the course of 3 months. And then at the end of those 3 months, all people, the two treatment groups and the control group, all completed the marital satisfaction inventory. So let's see what the results look like. Here is the output showing the results of the study. What do we have here? So we have here BCT, that's Behavioral Couples Therapy Group, in 29. There were 29 couples in that group. Their average, here's the mean score on the Marital Satisfaction Inventory, or MSI. This is that global distress scale. So a high score means you're more distressed. A low score means you're more satisfied and happier in a relationship. So their mean score was 56.87. The people in the insight-oriented group, 30 people in that group, their mean score was 54.06. And the control group receiving nothing, their mean score was 64, which looks like it's going in the direction of being a little bit higher than the other groups. In fact, if we want to get a ballpark estimate of effect sizes here for comparing differences between groups. Now, actually, this particular example, I'm going to start off focusing on Omnibus tests, where you say, overall, is there a difference between groups? That's going to be the focus right now. We're going to save the comparing individual groups for a bit later here. But we can jump ahead a little bit and just get a sense of how big are the differences between groups. For example, we see that the control group had a mean of 64, insight-oriented therapy was 54, so it's about 10 points of difference between those two groups. If we look over at our standard deviations, we've got 11, 9, 8. Just to give a very ballpark rounding, it's about 10 units is about one standard deviation. So if there's about 10 units of difference between these two groups, that's about, in the ballpark of a standard deviation of difference between those two groups, which would be a D statistic of 1, which would be a very large D statistic. So just rough ballpark here, it looks like we might be dealing with a fairly large effect. The behavioral couples therapy group, they're not quite, the difference is not quite as big. Their score is not quite as low as the insight-oriented therapy group. And so when we get to the question about what group is different from which group, the specific focused questions about how groups differ from each other, a question we're going to get to a bit later. But when we get to that, we can ask questions about, is the insight-oriented group different from the control group? Are the two treatment groups different from each other? So those will be important questions to look at. But for right now, we're going to focus on the omnibus question, which is overall, is there a difference between groups? And we can test that eventually we'll calculate an eta squared to get the percent of variance explained. And we can look at the significance of the eta squared with our F table, the ANOVA. We'll test the significance of that omnibus effect. And here we have an F statistic is 6.69. And the p-value, the significance of the p-value is 0.002. That is less than 0.05. So we definitely have a significant result here. We can say, indeed, there is a significant difference between these three groups. And we're going to continue on and focus on this omnibus question of just in general, is there a difference between groups? And then later we'll come back to the focused question about which groups differ from which groups. So what are the things that I would want you to do with this output focusing on the omnibus question? Well, one of the things I might ask is, I could give you this top part here that gives you the descriptive statistics. It has the mean and the standard deviations and the sample size for each group. I could just give you that information, and from that I could say, you complete the entire ANOVA table. From top to bottom, do the entire thing. You could reconstruct the entire ANOVA table just from these descriptive statistics listed at the top. So how would you do that? Well, let's see. The first thing is to figure out what is the total sums of squares for that goes down there at the bottom of your ANOVA table. So this is the total sums of squares and the outcome variable, or the Y variable. This is, in this case, it's the MSI, Marital Satisfaction Inventory Distress Scale, total distress score. And we see at the top here for the total, this is for everyone, our standard deviation is 10.52. So if you take your standard deviation, 10.52, and you square it, you will have a variance. And then if you multiply that by degrees of freedom, you will have your sums of squares. So we see we have our total sample size is 79. So 79 minus 1 is our degrees of freedom. And that gives our total sums of squares of 8,632.2912. So I'm going to just put that down at the bottom 8,632.2912, and that is our total sums of squares. Now the next thing, let's go to the top and get the explained sums of squares. Up here, let's fill in this top slot there. How did I plugged in 1,336.76. How did I get that number? Well, we need to calculate the explained variance sums of squares for each group. So what I'll do is I'll start with group 1. Their mean was 56.87. The total, the grand mean of everybody was 57.73. So I'll take how far group 1, 56.87, deviated from the grand mean to get that group deviation, and then I'll square it to get the group deviation squared. And then I'll multiply that by the group sample size, which was 29. There's 29 people in the group. So I take the group deviation squared, how far the group mean deviated from the grand mean, and square it to get the squared explained variance group deviation, multiply it by the sample size, and for group 1 I get 21.448. And then I'll do the same thing for group 2. I'll take their group mean. Group 2, their mean was 54.06. Again, the grand mean was 57.73, so plug that in, 54.06 minus the grand mean, 57.73, squared, times the group sample size. Group 2 had 30 people in it. So take my group deviation squared times the sample size, and for group 2, that is 404.067. And then I'll do the same thing for group 3. Their mean for group 3 was 64.48. Subtract from it the grand mean, 64.48, minus the grand mean, 57.73, squared, times the sample size. Group 3 only had 20 people in it. So I'll plug that in down here, times 20, and I get 911.25. So now I've got the sum of square deviations for each group, and then I'll just sum that together for all 3 groups. So I take group 1 plus group 2 plus group 3, 21.448 plus 404.067 plus 911.25, and I get the sum of all that equals 1,336.76. That is my explained variance sums of squares. So I will put that value right here at the top, my explained variance sums of squares. How far the group means deviate from the grand means. How far the group means deviate from the grand mean. And now I can just use subtraction to get my error variance sums of squares. I'll take my total variance, 8,632. Put that right here, 8,332. 8,632. There we go, put that up there. Minus my explained variance sums of squares, 1,336. And I get the difference is 7,295. And I plug that right here for my error variance sums of squares. So simple subtraction could get my error variance sums of squares. So now I have all my sums of squares, and the next step is to get degrees of freedom. So my total degrees of freedom, n minus 1. So I have 79 people. Oh, there we go, 79 people all together. So 79 minus 1, I have 78 degrees of freedom for my total degrees of freedom. And then for my explained variance degrees of freedom, that's number of groups minus 1. So I've got 3 groups minus 1. I have 2 degrees of freedom for my explained variance. And then for my error, I take 78 minus 2, my total degrees of freedom minus my explained variance degrees of freedom, and I get 76. So now I have all my degrees of freedom, and now I'm ready to calculate my mean squared. A mean square, take my total sums of squares divided by degrees of freedom to get mean square. So take 1,336.76 divided by 2, and I get 668. Take 7,295 divided by 76, and I get 95.9938. So sums of squares divided by degrees of freedom, and I have my mean square. And now I'm ready to calculate my F value. Mean squared numerator divided by mean squared denominator. That is, mean squared explained variance divided by mean squared error will give me the F value. So 668.38 divided by 95.9938 gives us the F value 6.9627. And there's the F. Note that in this example, as often happens, we're dealing with rounded values, so there's a few things in this example that do not quite match exactly what the SPSS output shows us, and that's just because we have rounded values and things don't exactly match. If we didn't use rounded values, then everything, of course, would match perfectly. But that is how we can reconstruct the ANOVA table just from the descriptive statistics listed at the top. What else? Well, I might ask you to calculate that effect size. What exactly is our eta squared? What is the percent of variance that has been explained? That's the same thing we've done all along. We take our, and recall that the eta squared is the same thing as capital R squared. When we're doing a regression, we call it R squared. When we're doing a comparison of group means, we call it eta squared. Again, I don't know who decided to call it different things for different types of analyses, but that's the way it turned out. So we call it eta squared, which is mathematically identical to R squared, where we take our explained variance sums of squares divided by our total. So 1,335, that's our explained variance. That's our numerator, divided by our total variance sums of squares, 8,628, to get the percent of variance explained. And so in this case, we've explained about 15% of the variance. Our eta squared is 0.1548. So we've explained about 15% of the variance. That is, knowing that we have people assigned to 3 different groups, that the effects of the treatment all together are explaining about 15% of the variance in the overall global distress scores of the people after they've received treatment. Now at this point, I could ask you that question regarding the 5 pieces of information pertaining to an effect size and an inferential statistic. This is where I give you a basic question, and I want you to answer the question by giving 5 pieces of information regarding what is the name of an effect size, what is the value for an effect size, what is the name of an inferential statistic, what is the value of that inferential statistic, and what is the p-value. And we can do all that for our omnibus question, and the omnibus question is, overall, is there a difference between groups? And so the effect size for that omnibus question, is there a difference between groups? The effect size, the name of the statistic, is eta squared. In this example, the value for that statistic is 0.1548. Then what is the inferential statistic that we can use to test the significance of that effect size? Well, the name of the inferential statistic is F from our ANOVA table. What is the value of our F? It is 6.96. And what is a p-value? What's the probability of getting an F value this big if the null hypothesis were true? Our p-value is 0.002. So that is how you would give the 5 pieces of information for this example if I asked the omnibus question, is there a difference between groups? Now, another thing we could do, instead of doing the eta squared, we could do omega squared. Now, as a default, if I just say, give me the 5 pieces of information for a difference between groups, just to be consistent with what we're typically doing in this class, by default, I want you to give me eta squared. But if I specifically say, please give me a descriptive statistic that has been corrected for bias, what I'm looking for there is the omega squared. And that involves just a little bit more calculation. Here we have to have the sum of squares explained variance. There's 1,335, and I'm going to put that right here, minus the degrees of freedom explained, which is the explained variance is your between groups variance. So we have 2 degrees of freedom for explained variance. So I'll put that right there, times the mean squared error. And in this formula for omega squared, we're going to plug the mean squared error. That same value is going to have a spot in the numerator and the denominator. So our mean squared error is 95.96, and it's going to go right there in the numerator. And it's also, that same exact value is also going to go right down here in the denominator. And let's clear all this and see. So the denominator is simply sum of squared total. This is our sum of squares total, 8,628, so that's right there. And then again, that mean squared error, 95.96, goes right there. And we plug all that in, and we get a omega squared of 0.13, about 13% of the variance explained. So if we're trying to correct for bias, a more honest estimate might be to say we've explained 13% of the variance. And that might be a better, more honest way to go. But by default, just to be consistent with other things we're doing in this class, we'll report the biased as a default. If I don't say otherwise, give me eta squared. If I just ask you for, is there a difference between groups, that'll be the default thing to report. And only give me omega squared if I specifically ask for it, or if I specifically say, give me a descriptive statistic that has been corrected for bias. And then at that point, you need to plug in the formula and calculate omega squared. What else? What are some questions I might ask given this data set? Here's a few different questions we could look at. And hopefully as we go through these will sound very familiar. You'll have this deja vu feeling like, haven't we talked about these questions before? And indeed, we have. So hopefully by this point in the course, these things are becoming very familiar to you. So for example, the question, what is the average distance of people's scores on the outcome variable deviated from the grand mean? Well, how far scores typically deviate from a mean? That, of course, is a standard deviation. Now, when we have group differences, at this point, we're wanting to clarify, are we talking about how far scores deviate from a grand mean, which is a total standard deviation, which would be different than how scores deviate from their group means, which would be the within group standard deviation. But here we're talking about how far scores deviate from the grand mean. That's just the ordinary, plain and simple standard deviation for the outcome variable, which our outcome variable is that total score on the marital satisfaction inventory. And the standard deviation is 10.52, so that would be the answer. What is the average distance of people's scores in the outcome variable deviated from the grand mean? 10.52. Okay, what's we have here? What is the average distance of people's scores in the outcome variable deviated from their individual group means? So that is that other type of standard deviation, how far scores deviate from their group means. And this is a point to keep in mind, that how far scores deviate from the group means is the same thing as a standard error of estimate. Because when I'm doing group comparisons, people's predicted scores are simply the group means. So everybody's predicted scores is the mean for whatever group you're in. And how far people deviate from their group means is the same thing as how far they deviate from their predicted values. So the typical distance people's scores deviate from group means is the same thing as saying what is the typical distance that scores deviate from their predicted values. And when we call it how far scores deviate from predicted values, we use the term standard error of estimate. When we talk about how far scores deviate from group means, we would call that the within group pooled standard deviation. And when people are looking at group means like this, they usually use the term the pooled within group standard deviation. That's the term they usually use, and they don't usually use the term standard error of estimate. But the truth is, those are all the same thing. Mathematically, it's all identical. It's just that when they do group comparisons, they don't typically use the term standard error of estimate. They use the term pooled within group standard deviation. So I have down here calculate a value that is analogous to the standard error of estimate. And I say analogous just because this term typically isn't used, but even though it's really the same thing. But we do the same thing we did before in previous units. If we want to get the standard error of estimate, we get our error, mean squared error variance, 95.96. And we simply take the square root of that. Do that up here. I take the square root of 95.96. I get 9.7959. That is the standard error of estimate. That is the pooled within group standard deviation. That is the average distance that people's scores deviate from their group means, which is the same thing as the average distance people's scores deviate from their predicted values. What else? We could say, what is the percent of variance that has been explained in this equation? And we've already looked at that. That, of course, is the eta squared. We calculated the eta squared previously, and our eta squared was 0.1548. So that is the answer. Percent of variance that has been explained, about 15%, 0.1548. what about this? What is the expected score for Y for a couple that is in group 3? Well, if you're in group 3, your expected score, your predicted score, is simply the mean for your group. So people in group 3, behavior couple is group 1, insight-oriented is group 2, control is group 3. The mean for that group is 64.48. So the expected score for Y for someone in group 3 is 64.48. Simply the mean for that group. Let's see, this question here is essentially the same exact question, just a slightly different words, but I'm asking it again. I say it this way: if Doug is in group 1, what is Doug's predicted score on the outcome variable? Well, we just looked at that question, except for now I'm asking about group 1. So if Doug is in group 1, that's the behavioral couple therapy group. The mean for that group is 56.87. So Doug's predicted score is 56.87. Then I can say if Doug actually received a score of 48 on this outcome variable, if that was his actual score on the outcome, what is the squared error for Doug in this study? So if he actually got a score of 48, that's his actual value on the outcome, and his predicted score was 56.87, to get the squared error, you take observed minus predicted, 48 minus 56.87, and you square it, and we have 78.6769. So that would be the squared error for Doug. And of course, in a study like this, we could calculate the squared error for every single person in the sample, or every single, actually, if this is a sample of couples, it would be every couple. So I guess it would actually be Doug and Doug's partner, whoever that partner is, because this is a study of couples, not of individuals. What is the typical squared error for participants in the study? So our mean square, now if I say what's the typical error not squared, that's the same thing as a standard error of estimate. We just calculated that a moment ago. But this question is asking for the typical squared error, and that is the mean square. The mean squared error, or the mean square within groups, which within group sums of squares, that's your error sums of squares. So 95.96. That is a typical squared error for participants in the study. Now, just a moment ago, we figured out that Doug's squared error, hypothetically, or Doug and his partner, their squared error was 78.6769. Given that, we can say, was the squared error for Doug and Doug's partner higher or lower than the typical squared error? Well, if the typical squared error is 95, the squared error for Doug is less. It's lower. There was less squared error for Doug than the typical error. And then finally, we have what is the sum of the squared errors for all the participants in the study. And of course, as I mentioned just a moment ago, every couple, every participant, every case will have an observed score, and we can take observed minus predicted to get the error and square it, and we can get the sum of all the squared errors for everybody, and that is exactly what we do when we calculate the within groups, the error sums of squares. So 7,292.69, that is the sum of the squared errors for all participants in this study. And I'm going to pause there. This is everything for the omnibus effects. And in the next section, we're going to look at the focused effects. If we want to compare specific comparisons between groups to see, say, for example, is the behavioral couple therapy group different from the insight group? Are the two treatments different from each other? And are the two treatments, say, different from the control group? So the next thing coming up shortly is looking at focused comparisons between groups.